Don't be a part of pollution, be a part of solution. Assalamualaikum warahmatullahi wabarakatuh. The Honorable Judges of YSIS 2020. Plastics are an important ingredient in the global economy and will continue to increase. According to Jambek et al. 2015, this increase is directly proportional to the amount of plastic waste produced. Indonesia is ranked second in the producer of plastic waste in waters with a total of more than 187 million tons. This fact is supported by the Ministry of Environment and Forestry regard the amount of plastic waste produced reaching more than 10 million plastic bags per year. In fact, the increasing amount of plastic waste can have serious impact on the environment. The type of plastic that is often used in the type of PET, which takes hundreds of years to degrade completely. Therefore, a solution is needed to overcome this problem. Several studies have revealed that there are microorganisms that can produce enzymes as degradators of PET plastic waste. One of these microorganisms is Fusarium solani, which is capable of producing cutinase enzyme.
Previously, there had been research on plastic waste degrading microorganisms. The first is the use of Fusarium solani directly, but has disadvantages such as less stable, low storage capacity, and less effective in recovery. The second is the use of Cutinase enzyme by immobilization method. The immobilization technique is a method of localizing enzymes in a matrix so that it can be used continuously, but has the advantage such as easily distorting protein configuration, steric barriers, and low diffusion rates, so that the research is less effective. For as the student of Brawijaya University, we brought to present potential study of Cutinase nanoimmobilization from Fusarium solani as PET degradative enzyme.
The purpose of this paper is to develop and optimize the work of Cutinase enzyme produced by Fusarium solani as a degradator of PET plastic waste through the nanoimmobilization method. Method include first draw up a framework, second data collection, and continued with analytical methods, and the final is conclusion.
Fusarium solani produces Cutinase enzyme with an optimal pH of 7.5 and an optimal temperature of 40 Celsius degree. The molecular weight of the enzyme reached about 24 kilodalton with kinetic value of 1.37. At present, many studies have used other microorganisms to express the cutinase enzyme from Fusarium solani. It aims to increase the production of the cutinase enzyme both in quantity and quality. Based on this characteristic, it can be seen that the cutinase enzyme of Fusarium solani expressed by Pichia pastoris is better than the other microorganism. Pichia pastoris has an enzyme activity of 3,950 mg. Therefore, in the production process of the enzyme cutinase, Pichia pastoris is used as an expressing microorganism.
Cutinase enzymes have been widely applied in the decomposition process of plastic, especially polyester. Recent studies have shown that the enzyme cutinase plays a very important role in the degradation of polyester such as PET, PCL, PBS, and other synthetic polyester. Based on the research, the polyester which was degraded by cutinase showed a change in thickness from 0.49 millimeter to 0.11 millimeter in 64 hours, as well as damage to the polyester surface due to enzymatic degradation.
Magnetite as a matrix of nanoparticles in enzyme nanoimmobilization can be made through physical, chemical, and biological methods. Each production method produces magnetite nanoparticle with special characteristics. From several studies, it was found that the chemical precipitation method was better than the others because it had the advantages such as simple and effective.
Research show that nanoparticles as immobilizing agent have the advantage of higher enzyme loading due to the wider surface area. The following are several methods of enzyme nanoimmobilization on nanoparticles. One of the superior methods is by means of covalent bonding, which the advantage that is can increase the operational stability, reusability, and have a long life. This method is classified as superior because the natural bond between the enzyme and the matrix which is formed is more stable due to the covalent reaction that occurs. So the enzyme is firmly bound the matrix, and this is leak proof. Based on existing research, the lipase enzyme, which has similar properties to cutinase, show the effect of non-immobilization on the characteristics of the enzyme, which becomes more tolerant of pH change, better thermostability, and higher hydrolysis activity. The following is comparison of the enzyme activity before and after immobilization in nanoparticle based on the temperature and pH.
It is also supported by other studies showing that the cutinase or triacylglycerol lipase has properties similar to lipase, so that the cutinase can still be classified as a lipase. That the nanoimmobilization method for cutinase provides several advantages, such as better kinetic potential, more stable pH and temperature, more constant inactivation kinetic temperature, higher inactivation and thermodynamic energy, and the ability to reuse so that it is more economical. Let's nurture the nature so that we can have a better future. Nani Molani, fast, precise, and usable.